Thank you, Deborah, for the nice introduction. Again, I see that we have a global audience today with people from the US and from Europe. So, good morning and good afternoon to everyone. Let me thank you for joining us. This is now the third time Safic-Alcan is organizing its own live webinar. This event is part of a new scientific trend series by Safic-Alcan. There are more webinars coming up yearly next year, so stay tuned. Next 40 minutes should be a nice journey through the exciting field of texture. On one hand, I don't have to convince you that texture is very important in cosmetics. On the other hand, we know very little about it. This is probably one of the most empirical parts of the cosmetic science. When you develop an effective anti-aging ingredient, there are thousands of markers that tells you about the mechanism of action, why it is effective or not. When I go down to our application lab and ask our formulators how they got this such a beautiful texture, well, it's not easy for my lab manager to explain why we have such a quick break, for instance. The idea behind this webinar is to bring some light around texture. If you have any questions, feel free to write them in. We'll be happy to answer them. At the end of the presentation, if your question has not been answered today, we'll come back to you via email. You will also get my details at the end of the presentation. If there is anything I can do to help you, well, just drop me an email. Quick view on the agenda. Our journey will start with understanding what texture really means for consumers. We'll look at some market examples, dig into product segments, and decode consumer needs and behaviors. Secondly, we'll ask Joey Hodges, an expert from the Center for Industrial Rheology Lab in the UK, to help us understand what texture represents technically. It will help us clarify key concepts such as rheology versus viscosity, structured versus elastic liquid, and so on. Then we'll try to build the perfect, innovative texture creator toolbox. It will include ingredients that thicken media, such as water and oil, others that provide unique suspensive properties and create novel gels and films. Our journey will end with a futuristic view on texture. I remember a very interesting presentation at the Dior Symposium where the speaker explained that in the shop, texture is the parameter that has the most influence on the purchase intent, right after the brand name. It is unique in the sense that it can stimulate two of our key senses, vision and touch. There's a motto that says that the first impression can only be made once. Texture is the criteria that will have the most impact on this first impression. Texture is gaining more and more momentum in the social networks. For instance, the hashtag Texture Tuesday was created in 2018 by a very influential blogger. On TikTok, which is today one of the trendiest networks, there are today 4.6 million video views with this hashtag. For sure, the COVID-19 crisis is having a huge impact not only on our personal life but also on cosmetics. One of the rising trends is the touch-free hygienic format. We see more roll-on, spray, mist, single-use capsule stick being launched. Solid products reassure consumers in terms of usage. They offer hygienic gestures while being effective. I would like to point out here also the link between the texture and the gesture. An innovative texture, such as solid format, may be at the origin of a new gesture. You can also imagine that in the current sanitary crisis, some trends such as nomad products and clean beauty are gaining momentum. How about developing the concept of clean texture? Here, you can see some examples of product capitalizing on touch-free hygienic trend. Bold offers completely hygienic single-use skincare drops. These biodegradable skincare capsules are made from sustainable seaweed. They are clean and travel-free. Milk has launched a solid body oil and a solid water gel. That's very interesting in terms of texture. In the Cruft Stuff range, we find a moisturizer in a spray-on format, which is fast and easy to apply. It is positioned around providing hygienic, contactless skincare. Do you know what was the #1 best-selling home equipment in France during the COVID-19 crisis? Bread self-cooking machines. This confirmed the rising consumer interest for do-it-yourself products because they engage, distract consumers. When you are confined at home, you want to experience some fun, some excitement. Keep in mind that this is the right time to develop playful sensorial texture to boost mood. Go ahead and create novel, surprising textures. Jelly, slime, mochi gestures, transforming texture. In fact, almost 7 young Italian consumers out of 10 will rather buy beauty products that are fun to use, like the slime shower jelly. Boschia has launched a unique and innovative jelly ball cleanser, which offers a playful and effective cleansing experience. Dr. Brand Magnetized Mask counteracts the aging effect of stress and pollution. Wazo by Shiseido offers you to mix a liquid and a powder to create your own texture. The warming sensation and the texture are said to relax skin and mind. Also in line with the need to have fun is the rise of the wow textures. Almost 40% of young European consumers reported to be interested in using color-changing, texture-changing products. This is why we see the rise of textures such as gel to water, cream to water, powder to cream, powder to mousse, and so on. L'Occitane has launched a powder to mousse facial exfoliator and mask. It becomes a sparkling mousse when in contact with water. Algenist offers a balancing color changing mask. It can be used until it changes color from light green to pink. Then you can rinse it off. Tatcha's water cream provides a unique water burst. The cream becomes a water-light liquid upon application. When we talk about quick break, do we really know what it means technically? What are the key parameters that characterize texture and how do we measure them? Let me introduce Joey Hodges from the Center for Industrial Rheology in the UK. I visited this company once and these guys are really amazing. They are experts in rheology for practical application in cosmetics and food. Joey's expertise is in translating complex concepts in easy to understand words. He produces and edits the best texture content you can find on YouTube, for instance. Joey, the floor is yours.
Thank you, Olivier, for the introduction and for inviting me to speak with you. It's a pleasure to be here today. Our lab at the Centre for Industrial Rheology is an independent lab based in the south of the UK, serving thousands of customers across the globe from multiple disciplines and industries, from cosmetics to pharma to food, anywhere where the physical properties of a product is important to its performance. Our company specializes in measuring the physical properties of soft materials by using multiple physical testing techniques, from rheology to tribology to interfacial tension and interfacial rheology and powder flow analysis. My specialty is in communicating what we do to the rest of the world, helping provide testing capabilities to those with none, testing capacity to those with some, and training and consulting to those who want to rock the world of physical sciences like we do, regardless of your prior technical knowledge or experience. I want to kick off with a video about assumptions, and feel free to try this at home, but don't drink the honey all at once. It's really not recommended. What we have is a low viscosity product, a mango fruit smoothie on the left, and a high viscosity product, a honey on the right-hand side. And you can see it's high viscosity because it's proving very difficult to evacuate from its container. When we go to pick up the low viscosity material and tilt the glass from side to side, you can see that it flows fairly easily. But watch what happens when we place a spoon upright in both products. Now, we would assume that the higher viscosity product would be better at supporting the spoon than the lower viscosity one. But actually, we find out that the reverse is true. The fruit smoothie is better at keeping the spoon upright, more so than the honey. Let's look at something more relatable to cosmetics, a spreadability experiment. On the right-hand side, we have a mayonnaise displaying high viscosity behaviors and taking a long time to flow out under its own weight. On the left, we have a golden syrup resisting our attempts to place it exactly where we want it. One might assume that since the mayonnaise is taking longer to flow out and level, that it has a higher viscosity. The golden syrup, whilst having a high viscosity, is still lower than that of the mayonnaise. But watch what happens when we go to spread them. The golden syrup drags the plate across the table, whereas the mayonnaise completely breaks down and spreads easily. This brings us to our first key idea, in that viscosity is not a single number. For non-Newtonian materials such as emulsions, suspensions, gels, and surfactant systems, the viscosity of these materials will change depending on how you interact with them, specifically in terms of the shear applied. non-Newtonian materials change their viscosity depending on the shear you've applied. And this is an important physical property for understanding how your product moves in a pipe or in a dispenser. The assumptions your consumer will have about how it will feel on the skin, and also the stability that you observe over time. And what we found in working with our customers in the cosmetics industry, that by far one of the most common behaviors is non-Newtonian shear thinning. When you get the full flow curve of a shear thinning product, it looks something a little like this. We have a shear thinning segment between two Newtonian plateaus. The infinite shear viscosity is a plateau at high shear rates, and the zero shear viscosity is a plateau at very low shear rates. This is interesting because the viscosity of that the zero shear viscosity is the viscosity of that product when it is at an at-rest condition. Here we have a flow curve for a popular pharmaceutical topical pseudocreme, and we've covered a huge range of shear conditions. Rotational viscometers will typically work within this range, depending on the spindle and sample, but we can see that there's some really interesting behavior that occurs outside of its capable range. At this point of the curve, it would take our spindle an entire week to complete a rotation. And at this end, we're rotating, which is pretty good considering that we can perform the entirety of this test in under an hour. The significance of this zero shear plateau becomes important when you realize that your formulation spends most of its shelf life under these very low shear conditions, and thus this is the viscosity that determines whether your droplets or particles are coming out of suspension. In this video, the simple formulation using Safic-Alcan TCG, we've suspended some particles in there so you can see that when we go to interact with the product, at first it appears to have a low viscosity. But as we know by now, there's something fishy going on here. When we stop interacting with the product, we can see these glitter particles bouncing back. They move when the container moves, but stay immobilized when we leave the product at rest. And in fact, when we measured the zero shear viscosity of this product, it came out 10 times thicker than honey. If you're looking to improve the physical stability of a product, then and preventing oiling out or sedimentation, then often the strategy is to immobilize movements of these particles. Formulators think that they have to trade sensory qualities for stability, but if you're able to increase zero shear viscosity and increase the rate of shear thinning, then you don't have to sacrifice either. And in fact, your colleagues and competitors are already using this strategy. This is a real-world example of a best-selling product that uses a high zero shear viscosity and rapid shear thinning behavior effectively to achieve stability without sacrificing on desired appearance and texture. The zero shear plateau of this body lotion is 1,000 times thicker than honey at rest, but this rapidly shear thins to a much lower viscosity during application. And viscosity isn't your only option when trying to describe physical behavior of a soft material. Take, for example, this petrolatum with holes from a number 7 spindle. Using a T-bar attachment with a helipath will provide a more repeatable and representative measurement, but this tells us more about the structure of a product than the flow behavior. And whilst this is a decent workaround for obviously structured samples that you can see towards the right hand of the slide here, you might be surprised at where you can find structure. While my CEO was waiting for his flight at a Japanese restaurant, he noticed in his miso soup that particles started to flock together and form these dense but highly delicate 3D structures. And it's wonderful to think that the physics going on here is the exact same that you would get occurring at the surface of the Earth. These dark areas are like tiny subduction zones where you have colliding masses forcing one another into the depths like tectonic plates. If you tried to measure these delicate structures with the rotational viscometers, you would likely destroy the very structure that you're trying to characterize. And in fact, flocculation is a common common cause of instability in a lot of various cosmetic formulations. And in fact, if all you have is a rotational viscometer, then everything starts to look like a liquid. In yet another video of our food, this time a leek soup, you should be able to see that the soup bounces back after I've rotated the bowl. Much in the same way you wouldn't check a panna cotta by stirring it with your spoon, we apply a small push or stress observe the deformation, and then relax, applying a bigger stress each time until we see that product permanently deform or yield. This is the fundamental principle that we use for checking structure, and you can see this is pretty much exactly what our rheometer is doing to the sample. Elastic or solid materials will deform in phase with applied stress and bounce back when the stress is removed. Imagine I had a plate of jelly that I slowly tilted from side to side. If I return back to being level, the jelly does too. And if I repeat the plate of jelly experiment, instead with a half-filled tank of water, the tank of water would continue to slosh from side to side long after I stopped tilting. If your sample wobbles, this is a classic smoking gun of elastic solid-like behavior. In this oscillatory stress sweep, along the x-axis, we have how hard we're pushing the material, and on the y-axis, we have the phase angle, which you can think of as a sliding scale telling us whether the observed behavior at a specific stress is 0 degrees, more elastic, more highly structured, and more solid-like, or 90 degrees, more viscous and more liquid-like with no structure or a completely disrupted structure. I like to think of this as a solid structure detector test. And whilst it may come as no surprise that yogurt displays solid-like behavior when you treat it gently, it may be surprising to see that something like a fruit juice or orange juice actually displays solid-like elastic behavior at low stresses due to sugars, pectins, and proteins forming that highly delicate three-dimensional structure. Of course, the structure is so fragile that it doesn't take much stress to break it, as you can see from this great big upward sweep in phase angle, but when it's sat in your glass, it is behaving like a solid. In this plot, where we're comparing a bunch of different face creams, we have the same test, an oscillatory stress sweep, displaying slightly different information. We still have how hard we're pushing, the oscillation stress on the x-axis, but on the y-axis we have complex modulus, the overall resistance to deformation. When it's high, you can imagine a product is stiff, like a cheddar cheese, but when it's low, it's more wobbly, like a jelly. And remember, we're on a logarithmic scale here, so the Clarence formulation shown in purple is 40 times more rigid than the Nivea body lotion shown in blue. We can use oscillatory testing to benchmark formulations based on their structural and solid-like properties. For both plots we've seen, you'll have noticed a plateau on the left-hand side, but once you reach a specific stress, we see quite drastic changes. This significant change is the yield stress of the material, and I would describe it as the stress at which significant change in flow behavior is achieved. Our customers love this test because when you couple it with viscosity data, it enables you to rapidly map out various textures in the market, identifying clusters of popularity or suspiciously barren areas where innovative textures could be. To quickly anchor this kind of test data back with what you see in the real world, you could imagine products with a high complex modulus and low yield stress are kind of like meringue mixtures. They form stiff peaks but deform easily upon the application of stress. Stiff structure but weak strength. A product with a low complex modulus and high yield stress will be a bit like a jelly. You can apply a lot of stress to the product without actually causing it to break or permanently deform. If you remove that high stress, it will bounce back. Soft structure, but high strength. Something we haven't touched upon yet is the duration or timescale of deformation for oscillatory measurements. This is particularly relevant for polymeric or surfactant systems, which display something called time-dependent viscoelasticity. In this example, in this video example, we have a hand soap, and we can see that when we move the container slowly from side to side, it flows like a liquid. But if we reduce the timescale of deformation and move it very quickly, we can see it bouncing around. These sorts of formulations will also often display rod climbing behavior. And when we look at an oscillatory frequency sweep, we're interested in which plot line for the moduli is higher than the other and whether a crossover occurs. If the test data resembles this plot in the bottom left, where the loss modulus is consistently higher than the storage modulus over long to short timescales of deformation, viscous flow behavior is dominant. If the test data resembles this plot, where the storage modulus is consistently higher than the loss modulus over long to short timescales of deformation, elastic, solid-like behavior is dominant. In both cases, you will either have a product that is more honey-like than jelly or more jelly-like than honey, respectively. Polymeric formulations will often display this time-dependent viscoelastic behavior, where over long time scales they will flow like a liquid, but over short time scales they will bounce like a solid. When I was learning about rheology, I struggled to get my head around G prime, G double prime, and G star. So I just wanted to share an intuitive way of thinking about viscoelastic moduli. If you miss anything I say and want to take your time to explore this in more detail, it's one of our most popular videos on YouTube. Just search storage and loss modulus for beginners. I want you to imagine squeezing a wet sponge. The overall resistance you encounter in squeezing the wet sponge can be thought of as the complex modulus, G star, the overall resistance to deformation. The resistance to being squeezed is going to come from a combination of the rigidity of the sponge, which you can think of as the storage modulus, and the contribution of the viscosity of the water, the loss modulus. The magnitude of the overall resistance to deformation is a result of both the elastic resistance and viscous resistance, as shown by this vector diagram. It's not a perfect explanation, but I hope it gives you a bit more of an idea in the contribution of each moduli, the loss and stores moduli, to observed behavior. Okay, so we talked about time-dependent viscoelasticity. If anyone has ever used a rotational viscometer and encountered the situation where viscosity just continues to change during the measurement, you may have what's called a thixotropic sample. Thixotropy is a time-dependent reduction in viscosity, but I like to think about it in terms of speed of recovery. In this video here, where we have rapid thixotropic recovery, we have a laponite gel that shows this high viscosity when it's not moving, but when you give it a shake, it rapidly shears down, and then when you stop shaking, that viscosity immediately recovers to what it started out with. In this second video here, we have a mustard. So you can see that it's displaying a high viscosity at first. We give it a shake and really go to town on it, disrupting that structure. And when we open that lid again, we can see that the viscosity hasn't quite recovered to what it was before we decided to disrupt it. And this can be a real problem. If you spec out a pump to deal with several thousand gallons of a product, base it on the viscosity after having just been pumped, your engineers, your process engineers are going to have a really bad time when they try to get the product moving again the next morning when the viscosity has increased maybe tenfold to a higher state over a long time period. Okay, to finish up on various techniques for characterizing texture, I just wanted to introduce tribology, the study of friction and lubrication, as a natural next step for exploring physical properties related to the sensory experience of topical cosmetic products. Rheology assumes that there is no direct skin-to-skin contact as a product is taken from its packaging and spread on the skin. But as the product is spread thinner and thinner, you will eventually achieve direct skin-on-skin contact, where it is better to describe the product as acting as a lubricant between these two surfaces. The interest then is not just in the dragginess of the product, but also whether the mode of lubrication promotes an intimate boundary condition, similar to what you would get if you were rubbing olive oil between your fingertips, or masks surface roughness by promoting fluid film lubrication. This would be akin to trying to squeeze a little bit of egg white between your fingertips. Once you have the data, you have to make it easy to identify value, outcomes, and next steps. Communication of findings to stakeholders is arguably just as important as the discoveries you uncover. We utilize a bunch of statistical tools outside the scope of this talk to pull it all together, but I just really wanted to finish off on a small sample of what we can do. We essentially broke down the sensory experience into 3 stages. Stage 1, the initial appearance and pickup, where we selected yield stress as a key metric since it best described the product's strength of structure. Stage 2, application spreadability, where we consider the influence of viscosity. And Stage 3, late stage application and afterfeel, where tribology was considered as key to simulating direct skin-on-skin contact. You can immediately see that these products listed down towards the bottom right-hand corner occupy different areas of sensory space. With further treatment of the data, you can quantify the difference between these 3 points in space. Maybe one is of good bounciness, the other is of bad bounciness, and then you have your development formulation, which sits in between. From there, you can give your formulation a score of bounciness to a benchmark by calculating the distance between these different points. This is a really and heavily simplified communication tool, which will help get your message across to non-technical staff members, maybe working in sales and marketing. And your more technical partners can deep dive with you into the data as you start to think about what processes or ingredients you can utilize to achieve a target texture. So whether you want to understand the texture present within a marketplace, a geographic region, whether you're trying to replace an ingredient or formulation without sacrificing physical properties that made it popular or desirable in the first place, whether you want to include a new ingredient formulation or figure out how best to market it, or if you're trying to address process optimization, scale up, or even what bounciness means to your demographic, a whole world of physical analyses is available at your fingertips. We work with almost any soft material you can think of that would be considered a cosmetic, be it delivered topically, subdermally, or transdermally. If the texture is important, we can help characterize it and contextualize the collected data for your application of interest. If you're hungry to learn more, check out our website, our YouTube channel, ask me a question after the talk, or contact myself or the team via email. I just wanted to say I'm really honored to have been presenting with you today, Olivier, and I'm looking forward to the rest of this presentation.
Thank you, Joey, for the nice presentation. By the way, if you missed some of the concepts here, don't worry, relax. The video will be available on replay very soon. I see a formulator like a painter, a good artist needs palette with a broad range of colors to be creative. Well, let's now discuss how to build your own innovative texture toolbox. Our starting point will be a texture roadmap that will help us navigate from one texture to another. The first thing formulators usually ask for is how to structure the liquid phase. In your toolbox, you should be able to thicken the phase to form a gel or a film. You should be able to deal with water or oil. If you are formulating an emulsion, you certainly need to suspend things. Some formulators may ask for a clear formula. And finally, you may want to have the choice between a synthetic and a natural ingredient. The first ingredient in your toolbox is Nourion Amaze XT. It's a thickener for an aqueous phase. It has great suspensive properties. It can make clear solution. Also, it is natural. As you may know, there are more than 5,000 products launched every year in Europe with xanthan. Formulators love it because it works under a broad range of pH, temperature, and salt conditions. But as you know, the sensory properties of xanthan, they are not optimum. It's a bit sticky, it's a bit stringy, so Nourion Amaze XT offers a very nice alternative. We checked in the lab, and Amaze XT is more effective than xanthan as a thickener at equal level, and it is significantly less sticky and stringy than the standard xanthan. As you can see on the chart, it capitalizes on higher yield stress values and therefore offers even better suspending properties than xanthan. Here again, this is the clear illustration of the need to measure more than viscosity. Please check Rheology. Amaze XT is a multi-application and robust tool for you. With Clarion Aristoflex Velvet, we stay pretty much in the same area. This is a synthetic ingredient with extra sensorial benefits and a great compatibility with organic solvent. Aristoflex Velvet is a polyacrylate cross-polymer, so here we are dealing with polyacrylate chemistry. Probably use it above 5.5, check for salt compatibility. You can make extremely clear gels with soft and velvety touch. As you can see in the formula on the right, with Aristoflex Velvet, you can formulate up to 80% organic solvent. It's a great tool for you to formulate hand sanitizers, which are very trendy product right now. With Safic Gel Trap, we start taking care of the oil phase, and the idea behind that is to start stabilizing it. Safic-Gel Trap is a tool that will help you formulate trendy concentrated emulsions. In this system, the continuous phase, which is the oil phase in yellow, is in lower amount, about 15%, than the discontinuous phase, which is the aqueous phase, in blue. The aqueous phase here represents about 90% of the formula, but it's still the discontinuous phase. We are talking here about concentrated water in oil emulsions. The water phase is structured with Sepinov EMT10. The oil phase is stabilized with EasyNov, which will go to the oil-water interface, reduce surface tension, and therefore stabilize the emulsion. With up to 90% structured water, you will get a light, fresh, and easy spread formula. Try the formula yourself, you'll probably feel the cushion and the comfort sensation. Well, it is at the origin of the well-being you may feel with this formula. This is what we need at the moment. Again, the previous formula was a water in oil concentrated emulsion. You may want to formulate an oil in water concentrated emulsion. In this case, you can use Azahi Pellicer, which is a natural Gemini surfactant. It has a unique structure made of two hydrophobic parts linked by a tripeptide. It allows Pellicer to be perfectly organized at the oil-water interface and create the famous D phase. It can create amazing transparent gels containing 80% oil, 90% of a mixture of water and glycerin, and 1% Pellicer. The final formula is a very effective makeup cleanser. Japanese people love it because the texture changes when you rinse it off with water. Also, you can use Pellicer on its own as a very effective emulsifier at low level. So, with Pellicer, we formulated products with up to 80% oil. With Elementis Benton Gel, we moved to a 100% oil phase system. By the way, we receive more and more requests from formulators to help them thicken oil. In fact, Elementis Benton Gel offers effective oil thickening and suspensive properties. It has shear thinning properties and provides a very nice silky feel on skin. The chart shows that with Benton Gel, G', which is the storage modulus, is higher than the G', which is the viscous modulus. As a result, the internal structure is good and unlikely to experience separation. In absence of Benton Gel, the G'' gets on the top of G'. It flows like a liquid, but there is a risk of separation over time. Again, this is a nice illustration of the value of doing rheology measurements. With polymer Experistogel, we have a patented mainly biosourced polymer derived from lipidic polyesters called estoside. It is a very innovative chemistry. With this ingredient, you can thicken polar and medium polar oils. It is thixotropic, it benefits from great suspensive properties. You can make transparent formula with it. A 100% biosourced version will be launched at InCosmetic Barcelona next year. Let's now pursue our journey with exploring the world of gels. We form gels when there are strong interactions between the polymer molecules. Well, this is the case with the Safic-Care TC range. These are carrageenans, which are extracted from red algae. When we have weak interaction, like with iota carrageenans, we make smooth and elastic gels. On the contrary, with kappa carrageenans, we make strong gel thanks to a very effective interaction between polymer strands. With Momentive Silsoft O, we capitalize on very innovative vesicles to make microgels. They include a cationic silicone shelf, which can interact with oils, and a polyacrylate core, which can swell with water. Vesicle can form a network that can stabilize the emulsions. Depending on the conditions, the size of the vesicle will vary. At neutral pH, they swell a lot, particle size will increase, and vesicles will be tightly packed and form butters or even powders. At low pH, where the polyacrylates are not very effective, remember, we discussed that before, we form light gels. For formulator artists that you are, this type of multi-texture technology should be really useful. Let's now move to the last area, which is film forming. We'll be talking about the Safic-Alcan TA range. These are alginates which are extracted from brown algae. Alginates are film formers, but you can also use them as traditional thickening agents. They benefit from pseudoplastic properties. The alginate polymer get organized in what we call the egg box model. In the presence of divalent like calcium, very strong bridges are created between the polymer strands which form films. On the video, you can see that we are applying an alginate solution on skin. Then we will spray some calcium chloride on it. And you can see that we can form immediately a film. This is the principle used by peel-off mask. When I look at the texture roadmap we discussed at the beginning, I think we've done a pretty good job in covering more or less everything. We started with Nourion Amaze XT and Clarion Aristoflex Velvet. These are two excellent thickeners and suspensive agents targeting the water phase. Then, with Sepic Trap and Pellicer, we started looking at the oil phase by stabilizing it. Logically, we moved to 100% oil-based systems with Elementis Benton Gel and Polymer Expert Estogel M. We looked at the principle of forming gels with Momentive, Silsoft O and Safic-Alcan TC range. Then we completed our journey by looking at the film forming properties of the Safic-Alcan TA range. Now let me try to share with you some perspectives and areas to explore. Remember that at the beginning I told you that we knew very little about texture, technically. We know how to measure viscosity, but that's not enough. Thanks to Joey's presentation, we know that there are plenty of other tools available to characterize textures. First of all, let's use these rheology and tribology tools. You can use them to do mappings and position your formula versus competition. You can file patents, you can do claim support and build strong technical and even marketing dossiers. Remember that our final customers are getting more and more eager to get technical information on the cosmetic product they use. How about explaining them what's behind their beloved texture? Also, use some of these tools to create wow formula. Again, this is the perfect timing to do it. I can hear some of you say that what we are missing is the link between some of these tools and consumer perception. I think you're right. Which part of rheology and tribology measurements are actually correlating with some of the attributes such as product pickup, playtime, evenness of the application, coverage, spreadability? Imagine that some of these tests, which takes between a few minutes and an hour, can correlate with what we see in a 4-week usage panel with 50 people. That would be wonderful. Some universities are being involved in this area. I'm thinking about the University of Le Havre in France, but a lot of work remains to be done. There's no doubt today that some perfumes have a positive impact on well-being. This is referring to aromatherapy. Retailers were amongst the first ones to use neuro fragrances together with smooth light and positive design to create calm and relaxing shopping experiences. Neurosciences are here to help us better monitor and understand consumer well-being. In fact, work is being done to see how textures can influence well-being and reduce stress. We need to establish the brain-texture connection. Which skin sensory receptors are specifically reactive to textures? Do you know that smell receptors found in the nose have been identified in other areas of the skin? So when skin is in contact with textures, what kind of neurosignals do these receptors send to the brain? Can texture change our emotions? Emotions are usually short, specific, like anger, sad, or happiness. Can texture impact mood, which lasts longer than emotions? And usually moods are either positive or negative. What neurosciences have done recently is start developing tools to measure mood and emotions. This is the emotional toolbox, yet another one. I cannot go through them in details, but they include monitoring brain waves, eye, face movement, blood circulation, and so on. Now we can start monitoring whether consumers feel positive emotions and well-being with a texture. Do they like it or not? Is it energizing or relaxing? In fact, work presented recently by Patrice Bellon, a neuroscience expert at the September IPCE Congress, shows evidence that indeed some textures can have a relaxing emotional effect. Let me stop right here and let you imagine that tomorrow you will be able to formulate textures that not only suspend things or provide quick break, but that will make people happy. Hey, by the way, send me your samples. I really want to try your happy texture. Thank you for your attention. Now we are about ready to answer your questions.